Hello and welcome class. So in last class we have studied about what is buoyancy and we learned that if any object has more density than in comparison to the density of liquid, then that object will sink, and if it has less density than the density of liquid, then that object will float. Now in today's class we are going to study the last topic of this chapter, which is Archimedes principle, where Archimedes is a name of that scientist. Okay, so let's begin by doing one activity. Activity number 9.7. Take a piece of stone and tie it to one end of a rubber string or a spring balance. Okay, let's suppose there is a spring and you have attached a stone. Okay, suspend the stone by holding the balance of the string. Okay, and this is the figure. A string or a thread, and you have suspended it. Now elongate the string or the reading of the string balance due to the weight of the stone. What you are doing? This is your holder, and you have attached a spring or a rubber, and you have attached a stone in the end of that string, rubber string or that spring, and you have to measure the elongation in the air, that how much that string has extended when you have attached the stone. Now slowly dip the stone in the water in a container. Okay, you have first measured this elongation, you have first measured this length. Now what you have did, you have put that object in the water. What you are going to observe? You will observe that this elongation in the string decreases. Okay, this elongation, the length of the string will decreases. And why it is so? This is because liquid is giving an upward force to the stone. That's why that elongation has decreases. Observe what happened to the elongation of the string or the reading on the balance. You will find that the elongation of the string or the reading of the balance decreases as the stone is gradually lowered in the water. However, no further change is observed when the stone is getting fully immersed. Okay. When you have immersed the stone, you will start seeing the decrease in the length of that rubber string. But when that stone is completely immersed, you will not see any further changes. Now, why it is happening? What do you infer from the decrease in the extension of the string or the reading of the spring balance? What you will conclude from this decrease in the extension of the rubber string? So first question is why that elongation happened. This from here you were holding, this is your rubber string in the original length. When you suspended it, the rubber string is elongated. Okay, it is elongated. But why it is elongated? It is elongated because of the weight of the stone. Okay, when you put this in water, what is happening? Water will exert an upward force on this object, because of which this elongation will decrease. Okay, what water is providing? Water is providing an upward force on the stone. That's why that elongation has decreased. As a result, the net force on the string decreases and hence elongation also decreases. The force of gravity, which is causing that elongation when there was no liquid, that is decreased by the water by an upward force. That's why that elongation is also decreasing. And we know that this upward force is known as buoyancy or force of buoyancy. But if you want to calculate what is the magnitude of this buoyancy force, how you are going to calculate it? If I will ask you to calculate how much this buoyancy force is exerted by this pen, how you are going to calculate it? This is the question. And Archimedes' principle will try to find the solution of this question. Let's see how. Okay. Do all body in given fluid experience the same buoyant force? Does I and this pen both will exert same buoyant force if we both are immersed in water? To answer this question, we have to first understand what is Archimedes' principle. And Archimedes' statement is, when a body, this is the definition or the Archimedes principle, when a body is immersed fully or partially in a fluid, it experiences an upward force. It experiences an upward force equal to the weight displaced by it. Let's suppose there is a container. What this line is saying, let me explain you. This is the container, okay, which is completely filled with a liquid. Completely filled with the liquid from the top, okay. Now you have placed a stone here which started sinking, and as it will start sinking, some water will fall out from this container, okay. So how much upthrust force this object has felt or experienced will be equal to the mass of this displaced weight. To make it position, we have to displace some water to make, because the stone has taken the position of water. It means what the stone has done, the stone has displaced some water, and this is that displaced water, that much water the stone has displaced. So if we calculated the weight of this displaced water, then that will be equal to the upward force exerted by this object. Is it clear, class? So Archimedes' principle says that upward force is equal to weight displaced by weight of the fluid, weight of fluid displaced by the object, displaced by the object. Is it clear, class? And this statement is Archimedes' principle, that the upward force is equal to the weight of the fluid displaced by the object. And to understand it further, okay, what will happen if that stone which we have attached from the elongated string is fully immersed in water? What will happen with that stone? Okay, so the upward force which that stone will be exerting will be equal to how much the water that stone has displaced. Let's learn a little bit about Archimedes. Archimedes was a Greek scientist. He discovered lot of phenomena. He discovered the principle, Archimedes principle, which is named after him after noticing that the water in the bathtub overflowed. Okay, there is a long bathtub. Okay, he sit on it, and the water in a bathtub overflowed when he stepped into it. Okay, this is the bathtub. This is the object. It was firstly fully, uh, it was filled completely. When any object stepped on it, lots of water has overflowed it. Okay, And just by looking at this effect, he understand completely that the water displaced by him will be equal to the upward force exerted by him. This is the picture of the scientist Archimedes. Okay, when that happened, when he realized that the upward force will be equal to the water uh, displaced by that object, he ran through the street shouting "Eureka!" Eureka means "I have got it." And this knowledge helped him to determine the gold, purity of the Archimedes gold in the crown made for the king. Okay, the king of Greek has a gold crown. Okay, and the king wants to know the weight of that crown, or the purity of that gold which was in crown. Okay, so how you are going to check the purity? Just put it in the fully filled water beaker container. Okay, put that crown inside it. So the crown will displace water, and that upward force will be exerted by the upward force will be equal to the water displaced by it. And when you will measure the weight of the water displaced by it, you are going to calculate the upward force, and by the upward force you can determine how much pure that gold was. Archimedes' work in the field of geometry and mechanics made him famous. His understanding of the levers, pulley, wheels, and axle helped the Greek army in their war with Roman army. Okay, so with this information, this chapter is completed. We have learned what is Archimedes' principle. Okay, upward force is equal to how much water is displaced by the object. Weight of the water displaced by the object. Is it clear, class? So let's take a quick revision of this chapter, what you have learned. Okay. The laws of gravitation state that the force of attraction between two objects, the force of attraction between two objects is equals to directly proportional to product of their masses and inversely proportional to the square of the distance between them. This is an universal law applied on every object. Every object attract other object by this formula, by this force given by this formula, F equals to G m1 m2 divided by their distance square, where G is the universal gravitational constant. Its value is 6.67 into 10 raised to the power minus 11 Newton meter square divided by kg square. Clear, class? This is the formula for the gravitational constant, universal gravitational constant, and this formula is applicable for all the object in the universe, from planet to stars to human beings to the small pen to the atom. This formula is applicable to every object which contains mass. So such law is said to be universal. Gravitational is a weak force unless large mass are involved. Okay. We cannot feel the gravitational force between this object and between me. Okay, because the masses are very low. But when it comes to the large mass, like the mass of a star, of a sun, of a planet, then gravitational force is not that weak. The force of gravity decreases with the altitude. Altitude means distance. If difference increases, the force of gravitation will decrease because it is inversely proportional to the force of the gravitational. Okay. So as height increases, the force between Earth's gravity and any object will also decreases. It also vary on the surface of the Earth, as we know that the surface of the Earth is not completely spherical. It is little bit ellipse shape. At equator, gravitational force is less because the distance between core of the earth and the surface of the earth is large, and at poles the value of gravitational force is higher because the radius is small here. Is it clear, class? The weight of a body is the force with which the earth attracts it. Okay? Weight of a body is the force with which earth attract it. Mass into gravitational acceleration, where the value of gravitational acceleration is capital G, capital M divided by R square, where capital M is the mass of the earth, capital R is the radius of the earth, G is the universal gravitational constant, and weight is equals to mass into acceleration due to gravity or gravitational acceleration. The weight may be changing from place to place, but mass is always constant because weight depends on the value of gravitational constant, gravitational acceleration, and gravitational acceleration changes to place, so weight change from place to place, but mass is independent of it. Mass remains constant everywhere. Then we have learned about what is thrust, what is pressure. We also have compared the weight of any object on the moon divided by weight of the object on the earth. Okay. Then we learned about thrust, we learned about pressure, we learned about buoyancy. Then in the end, we have learned about Archimedes' principle, and Archimedes' principle has many applications in the real world. Is it clear, class? Archimedes' principle is used to design ships, submarines, okay, lactometers. It is a device which is used to determine the purity of the milk, and hydrometer, which used to determine density of any liquid, are based on Archimedes' principle. So Archimedes' principle plays a huge role in our daily life. All the objects which experience a force of buoyancy when they are immersed in water. Any object will experience, all the object will experience a upward force which is buoyant force when they are immersed in a liquid. Object having density which is lesser than the density of the liquid, then that object will float. And if the object has density greater than the density of the liquid, it will sink. If the density of the object is more than the density of liquid, it will sink. If less, then it will float. Let's solve some questions. Okay. You find your mass to be 42 kg on the weighing machine. Is your mass more or less than 42 kg? What will be the answer according to you? You find your mass to be 42 kg on a weighing machine. Is your mass more or less than 42 kg? On the weighing machine, measure the mass. Okay. On a weighing machine, mass is measured by comparing the weight. So when your weight of a body is an upward force, acts on it, cause the machine to show your weight less than the actual weight. Okay. This is your machine, weighing machine. You are standing on it. How a weighing machine measure the weight? First, you are applying an downward force on the weighing machine, which is mg. Okay. And in the reaction of this mg force, it will apply upward force. Okay. And it will measure the upward force, which is always lesser than your actual weight. So weighing machine always tell you your weight which is lesser than your actual weight. Clear, class? Question number 2. You have a bag of cotton and an iron bar. Each indicate a mass of 100 kg when measured on a weighing machine. in reality one is heavier than other. Can you say which one is heavier? Okay, a cotton ball with mass 100 kg and a bar of iron will have mass 100 kg, but in reality one of them is heavier. Which one of that is heavier? A bag of cotton or a iron bar? Which one is heavier? Both has same mass. And the answer is actual weight is actually the sum of your measure weight and buoyant force. Okay, the upward force which is measured by the weighing machine. So the bag of the cotton is heavier since it is larger than the iron bar. Okay, this is your mg and it will exert an upward force. So weighing machine will calculate mg minus upward force. Okay, and because cotton ball will have larger mass and it is exert, so it will exert a higher upward force, but its actual mass will be higher because both are 100 kg. The upward force is higher, so it has to increase, mass has to increase to balance out, and final answer to be 100 kg. So the cotton bag will have higher mass actually than iron. Okay, because iron exert less upward force, it will exert less upward force, so its mass will be less actually. Okay, is it clear, class? Let's solve some exercise question. How does the force of gravitational between two objects changes when distance between them is reduced to half? Two object mass m1 and m2 was initially placed at a distance d, then we have decreases its distance by half, reduces it by half. How the gravitational force changes? Can you calculate it? So what will be the value of gravitational force F in new case? In first case, it will be G m1 m2 divided by d square. Okay, what will be the gravitational force in second case? It will be G m1 m2 divided by d by 2 square. Calculate F dash. F dash will be 4 G m1 m2 divided by d square, and we know that G m1 m2 divided by d square is F. So F dash will be equal to 4 times of initial force. So when you reduce the distance by half, the force will increase 4 times. Is it clear, class? Okay. The situation is clear. Two mass which was originally separated by the distance t, then what we have done, we have reduces the distance to half, means the new distance is now d by 2. What we have done, we have calculated the force in both the cases and then we just compared the forces and we get the answer that if we reduce the distance by half, the new force will be the 4 times the older force. Is it clear? Consider the universal law of gravitation. According to that law, the force of attraction between two bodies is F equals to G m1 m2 divided by r square. According to the universal law of gravitation, m1 and m2 are the mass of two bodies, g is gravitational constant, and r is the distance between those two masses. Given that the distance is reduced to half, so new distance r dash is 1 by 2 times of the r. So f dash will be g m1 m2 divided by r by 2 square. Okay. So f dash will be 4 times the older force. F dash is equals to 4 times F. Therefore, once the space between object is reduced to half, then the force of gravitational will be increased by fourfold the first force. Means 4 times the first force. Is it clear, class? As we decreases the distance, the gravitational force of attraction is increasing 4 times. So this question is clear. Now next, let's move on to next question. Gravitational force act on all object in proportional to their mass. Why then heavier object do not fall faster than a lighter object? We know that the gravitational force is directly proportional to the product of their masses. If we have two objects, one has mass m1, one has mass m2, and m1 is greater than m2, it means, let's suppose it is an iron ball and this is a plastic ball. Okay, we released it at same time. We will going to observe that both object reach the ground. Both object will reach the ground at same time. Reach the ground at the same time. Why? What is the correct answer according to you? So as we know that the phenomena which is responsible, the quantity which is responsible to these two objects to reaches the ground is gravitational acceleration, and value of gravitational acceleration is independent of the mass of the object. It is independent from the mass of the object. That's why both the object, despite of higher mass or lower mass, both the object will reach at the same time. Clear, class? All the object fall from the top with a constant acceleration is called acceleration due to gravity, denoted by small g. This is constant on Earth, and therefore the value of g does not depend on the mass of an object. The value of g does not depend on the mass of an object. Hence, a heavier object does not fall quicker than the lighter object, providing there is no air resistance, no drag, okay, no air is blowing, okay. So both the object will reach the ground at the same time. Next question is, what is the magnitude of gravitational force between the Earth and 1 kg of object? We have to find the value of gravitational force between Earth and the object of the surface. There are two ways to calculate this question. One is to use this one formula, which is equals to G capital M small m divided by R square. And we know the value of G, we know the mass of the Earth, we know the radius of the Earth, and small m is given 1 kg, and calculate force. Other way is, what is G capital M divided by R square? It is actually small g. So force is just mg, mass is 1, g is 9.8. The final answer is 9.8 Newton. Simple. Okay. So you do not have to do hard work to solve this question. If you can see that g m divided by r square is small g, and we know the value of small g, which is 9.8 Newton. So if you go in traditional way, you will use this formula, F equals to G m1 m2 divided by r square. You will put down the value of mass of both the object, radius of the earth, value of gravitational constant. You have put down all the values and you have calculated, and final answer is 9.8 Newton, or simply use mg. If you have hold on the theory, okay, and you remember all the formula, all these questions are very easy. Okay. So in today's class, we have completed our chapter gravitation, which is chapter number 9 of class 9th NCRT. We have studied what is gravitation force, what is universal law of gravitation. We have learned about the application of universal law of gravitation. Then we learned what is mass, what is weight, and what will be the mass of any object on the moon. Then we move on to the next topic, next part of this chapter, which include thrust, pressure, buoyancy, and Archimedes principle, and why any object does not sink, or why some object float because of their densities. Clear, class? So, and we have solved some questions related to each of the topics. So this chapter is completed. I hope this chapter is clear to all of you. Thank you so much.